All right, guys, so we are going to have this video going over all four problems of the practice. So please make sure you complete this. It'll be good practice, and then you'll also be able to use this practice worksheet on your quiz tomorrow. Okay, let's get started. All right, so feel free to pause and fast forward through the video as needed. So identifying our key features, degree is talking about the highest exponent. Here the highest exponent is 3. Since 3 is an odd number, we're going to have an odd graph. Our leading coefficient, that means the front number, is a positive number. And since it's positive, the leading coefficient tells us what the right hand is doing. So if it's positive, that means our right hand is going up. So if our graph is an odd graph, the right hand is going up, that means the left hand is going down. Our y-intercept is going to be the constant. And what we talked about in class yesterday was that the constant means it is the number at the tail end of our polynomial that is not attached to a variable, a letter. So this would just be the plain number. In this case, we don't have one, so we can say that the constant or the y-intercept is at 0, 0. The zeros we will determine here at the bottom in just a moment. As for the end behavior, as x approaches infinity, that's going to the right. What is the right hand doing? It's going up towards positive infinity. As x approaches negative infinity, that is towards the left hand, what is the left hand doing? It's going down towards negative infinity. All right, now let's work on the factoring here. So anytime we try to factor a polynomial, we're going to copy down the polynomial first and foremost. 4t cubed minus 5t squared minus 6t. Set it equal to 0. Now, all three of these terms have something in common, and that's t. So we're going to factor out the greatest common factor, the GCF, which is t. When we factor out a t from each of these terms, we are left with 4t squared minus 5t minus 6, still equal to 0. Now we can go ahead and focus on this set of parentheses right here, and we're going to do the ABC thing where this is A, B, and C. We're going to multiply A times C, which is 4 times negative 6. That gives us negative 24. So we're looking for factors of negative 24 that add up to our B value, negative 5. Oops. Just trying to scoot that over a little bit. Okay, we'll just leave it there. It's okay. I'm going to move it because I don't like it how close it is to my t-chart. Okay, so factors of 24. We got 1, 24. We have a lot of factors of 24. 2 and 12, 3 and 8. All right, that gives us the 1, 3 and 8. If we have a positive 3 minus 8, that gives us our negative 5 that we're looking for. So we're going to split this middle term here into positive 3t minus 8t, bring down everything else. Okay. Now, we have 4 terms on the inside, so we can go ahead and group them. What can we factor out from the first section, the first grouping? Well, we can only take out a t. From the second section, we have negative 8, so we got to factor out that negative. From 8 and 6, we can take out a 2. So our first set of parentheses will be t minus 2. And the second set will be what we're left with. So if we say negative 8t divided by negative 2, we're left with 4t. If we say negative 6 divided by negative 2, we will be left with positive 3. And let's double check that other side to make sure that we can that this does that this here is what we're left with on both sides. So 4t squared divided by t does give us that 4t. 3t divided by t leaves us with 3, so we are good to go there. All right, now we can set all of the terms or sets of parentheses equal to 0. So we will say t equals 0, t minus 2 equals 0, and 4t plus 3 equals 0. Solving for t, we already have 1 here. Next we have this one. We'll add 2 to both sides, giving us t equals 2. This one has an extra step here. All right, we got our 3 zeros. Let's go ahead and write those in the space up here. So our zeros are 0, 2, negative 3 over 4. Let's go ahead and plot them on the graph. 0, I'm going to zoom in. 0, 2, and negative 3/4 is going to be about right there. Okay, let's also plot our y-intercept. It's just 0, 0, so we're good there. Okay, we know from our key features that the right hand is going up and the left hand is going down. And then everything in the middle just connects. There we go. Something like that. And we talked about this in class today. If you do yours like this, that is fine too. I'm not worried about the maximum or minimums here. We're just wanting to get a general idea of what the graph might look like with the right and left hand, whether they're odd or even, the zeros, and then the y-intercepts. All right, moving on. Number 2. What is our degree here? The highest exponent here is 3. With that number being odd, we know we have an odd graph. The leading coefficient is a positive 1. Positive number tells me that the right hand is going to be up. Since it is odd, I know that the two hands are going in different directions. So if the right hand is going up, that means the left hand is going down. What is my y-intercept? Remember, that's the constant. And here we have negative 4. So our y-intercept will be at 0, negative 4. Our zeros we'll find later. And behavior. As x approaches positive infinity, that's the right hand, it's going up towards positive infinity. As x approaches negative infinity, that's the left hand, it's going down towards negative infinity. All right, let's go ahead and copy down our polynomial so we can start to work on it. All right. So first things first, let's see if we can factor this by grouping. So we have 4 terms, so we can go right into factor by grouping. From the first section, the greatest common factor we can factor out is going to be an x squared. From the second section, we can take out 7 and 4. It's negative, so we got to take out a negative 1. Neither 7 or 4 have any factors in common. So our first set of parentheses will be x squared minus 1. Let's see, when we divide negative 7x divided by negative 1, we're left with 7, 7x. When we divide negative 4 divided by negative 1, we're left with positive 4. Okay, let's check the left side and make sure it matches. X cubed divided by x squared, is that 7x? No. Negative 2x squared divided by x squared, is that 4? No. So this cannot be factored by grouping. Actually, I'm just going to cross this one out. All right. So since we cannot factor by grouping, I'm going to say, let me write this in smaller letters so you can see it better. Doesn't work on both sides. So when we find out that factor by grouping doesn't work, then we need to go into P over Q. So I'm just going to rewrite my polynomial because that looks a mess up there. Q minus 2x squared minus 7x minus 4. There we go. So here is my P, and here is my Q, which is just 1. We'll start our little chart where at the top P equals 4, and at the left Q equals 1. We're not worried about this negative here. We're just looking at positive numbers because all of our possible solutions will be listed as plus or minus anyways. So not having the negative here doesn't change our possible solutions because our possible solutions cover both positive and negative versions of all of our numbers that we're using. So here's our little chart. P equals 4. So we're going to have all our factors of 4. We got 1, 2, and 4. So P goes on top, Q goes on bottom. So that leaves us with possible solutions of plus or minus 1, plus or minus 2, and plus or minus 4. All right. So now we're going to go into determining which of these possible solutions or maybe I don't say possible solutions. I want to say possible x-intercepts. So there are two ways we can find whether these are x-intercepts or not. You can take your time and plug in every single possible number. So you plug in positive 1 to your original equation. Then you plug in negative 1. Then you plug in positive 2, then negative 2, then positive 4, then negative 4. And you just keep going down the line. If when you plug in those numbers, if you plug it in and your polynomial simplifies to 0, then that is a x-intercept. That's an x-intercept, that's a 0, that's a solution, that's a root, whatever word you want to call it. If you plug it in and you get a different number like 5 or 3/4 or whatever number that you might get, then that is a point on the polynomial on the graph. But again, we don't care about these extra points right now. We're just worried about finding the x-intercepts and what the right and left hands are doing. Okay, so I'm going to show you the first way, 2 ways to do this. 2 ways to find roots. The first way, plug it in. And the other option is synthetic division. The plugging in is definitely the easier option, but the synthetic division, I think, is less time consuming. So here we'll do the plugging in first. So let's say we plug in positive 1. We're starting with positive 1 here. So we'll plug it in for x. So we have, oh, that looks awful. Okay, so we'll say 1 cubed minus 2 times 1 squared minus 7 times 1 minus 4. So here we're plugging it in. And let's see, 1 cubed, that's just 1. 1 squared times negative 2 is negative 2. Negative 7 times 1 is just negative 7 minus 4. So 4 plus 7, 11, 12, 13. 1 minus 13 is negative 12. So this is not a root. Okay, so if you were deciding to just do the plug-in, you can plug in every single one until you find all 3 roots. Personally, I don't want to do all that work. So I'm going to do the synthetic division. So for the synthetic division, we already did 1. Let's try negative 1. So you'll just do synthetic division for each of the numbers until you find a root. So starting with the synthetic division of negative 1, that's going to be -1 here. Okay, -1. So synthetic division, our thing started with coefficients of 1, -2, -7, -4. We bring down that 1. 1 times -1 is -1. -2 minus 1 is -3. 3 times -1, sorry, -3 times -1 is 3. -7 plus 3 is -4. -4 times -1 is 4. -4 plus 4 is 0. So if you do the synthetic division and you get a remainder of 0, then we know that number is a root. So what I'm going to do actually, instead of writing that, I'm going to say -1 comma 0. Put a box around it just so it's something easy for my eye to catch. I'm going to rewrite my quotient here in with the x's. We know when we divide synthetically, however many x's we started with, we're going to have one less. So we began with an x to the 3, so our answer is going to start with an x to the 2. I guess there's a 1 there. Okay, but x squared minus 3x minus 4. Okay, so let's talk about this -1. If x equals -1, we want to find what the original factor was. So x plus 1 equals 0. Now we have this nice x plus 1 in factored form. So we have this times x plus 1. And now we're going to factor this first parentheses here. So we have 3 terms. So we're going to go into doing a times c. So 1 times -4 is going to give us -4. And we want factors of -4 that add up to -3. So in this case, it's going to be +1 and -4. Because our a value here is 1, we know that our factors are going to be x are going to be the two factors we chose here, x plus 1, x minus 4, bringing down that x plus 1. Now, if you notice, we have two x plus 1s here. That is something we learned yesterday called multiplicity. And what happens when we have a multiplicity? Well, this is where we use the word bounce, because the graph is going to come up to the to that point, and it's not going to grow, it's not going to cross through it, it's going to bounce off of it. So it's going to hit that point and bounce back down in the other direction. So when we write our solutions up here, we'll start getting ahead of myself. Let's take a moment to set this all equal to 0 to get our actual x values for the graph. So we have -1, or, and of course this is the same one, -1. There's our bounce. So what we're going to do is rewrite these in the answer space for the zeros, and we're going to say -1, and in parentheses we'll say m2. That means multiplicity of 2. And then we'll say 4. Okay, let's go ahead and plot these points, these x-intercepts on the graph. 4 and -1, where this is a bounce. Just making a note of it. Okay, we can go right into graphing. So we know that the right hand is going up. Oh, that is too thin. Right hand is going up, left hand is going down. This is a bounce. Oh, and we need the y-intercept too, right here, -4. There we go. So it's going to bounce off this point, come down, and come back up. So our graph should generally look like that. All right. Let's go ahead and move on to number 3. 2 more, we're almost done. All right, here we're given zeros. So when we're given zeros, we can go ahead and plot them. We have 0, 7 over 2, which is 2.5, and 1. All right, we don't know any of these key features yet because we have to work backwards from the zeros. So if we have zeros, that means x equals 0, x equals 7 over 2, and x equals 1. We're going to work backwards here. So see how on the last one we ended with x equals. We ended with our zeros. Here we're starting with our zeros. So we're starting here and we're going back to this. Okay? So the way we do that is here. Oh, shoot. Make sure my video is still good. All right, we're still going. Okay, so if x equals 0, that means we just had an x out front. So that's good there. If x equals 7 over 2, that means we would multiply both sides by 2 and then to subtract 7. So we have 2x minus 7 equals 0. Then here x equals 1, subtract 1, we get x minus 1 equals 0. Okay, so those are our three steps, our three little initial steps here that we started with before getting those zeros. So now we need to write these in factored form. I'll go back up to show you. So now we're here where I put the little star, and now we're moving back here where we have our factors. So to write them as factors, we're going to say x, 2x minus 7, x minus 1. All right. Now, because we're trying to find our the original polynomial we started with, it got us these zeros, so we're going to FOIL everything back together. So we'll say x times 2x, 2x squared, x times negative 7, negative 7x, all right? And then we'll FOIL that to the x minus 1. 2x squared times x is going to give us 2x cubed. 2x squared times negative 1 is negative 2x squared. And then negative 7x times x gives us negative 7x squared. And negative 7x times negative 1 is positive 7x. So this is our original polynomial. Well, actually not yet. We can actually combine these two because they're both x squared. So 7, 8, 9, that means we have 2x cubed minus 9x squared plus 7x. This is our original polynomial. I'm going to copy this down into, I'm just kidding, we'll just zoom out. So looking at this polynomial, what is the degree? The highest exponent? 3. My leading coefficient is positive, so that tells me my right hand is going up. The degree being 3, 3 is an odd number, so if the right hand is up, the left hand is down. What is the y-intercept? Well, there's no constant here, so our y-intercept will be going through the origin. The zeros, we already know the zeros. They told us in the beginning. 0, 7 over 2, 1. All right, so with our odd or even little picture here, as x approaches positive infinity, the right hand is going up, and as x approaches negative infinity, the left hand is going down. All right, now we can go ahead and graph our polynomial now that we know what the right and left hands are doing and our y-intercept. Our y-intercept is going through the origin, which we've already plotted that 0 there, so we don't need to plot anything else. Now we're going to look at the right and left hand. Right hand is going up, left hand is going down. Then this will just go something like that. Oh, yeah, yes. I thought I forgot the y-intercept, but I already said it's 0, 0, so we covered that. Okay, perfect. Number 4, last one. All right, what is my degree here? Highest exponent. 4. What is my leading coefficient? Positive or negative? Positive. That means the right hand is going up. So is this graph even or odd? Well, the degree of 4 is an even number. If the right hand is going up, that means the left hand is also going up. So as x approaches positive infinity on the right, we're approaching positive infinity. And as x approaches negative infinity on the left, we are approaching positive infinity. The y-intercept, there's nothing, no constant listed here. So we can assume our y-intercept is at 0, 0. Okay, now we need to find our zeros. Let's rewrite our polynomial. That's a little bigger. 3x to the 4 minus 27x squared equals 0. All right. Now, is there anything from both of these that we can factor out here? We can factor out an x squared, for sure. What about a number? 3 and 27, we can factor out a 3. So if we factor out a 3x squared from 3x to the 4, we are left with x to the 2. If we factor out a 3x squared from negative 27x squared, 27 divided by 3 is 9. There we go. Do you see what I see? We have a difference of squares. So that x squared minus 9 is going to factor to x plus 9, x minus 9, bringing down that 3x squared. Now we can go ahead and set all three, the parentheses and then any terms that have been factored out, equal to 0. So we shall say 3x squared equals 0, x plus 9 equals 0, x minus 9 equals 0. Okay? So I'm just going to start with the right because that's going to be the simplest one. X equals 9. X equals negative 9. Moving towards the left, we have 2 divided by 3, which still gives us 0. And then take the square root of 0, which is still 0. Okay, so here we have roots at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9, and positive 9. All right, those are our 3 zeros. Oh my gosh, I'm so sorry. I realized I made a mistake. When we took the difference of sums here, I said x plus 9. It should be 3 because the square root of 9 is 3. So I apologize for my mistake. Hopefully you caught it and you were wondering, what the heck is wrong with you, Miss O? Well, I don't know. I do some crazy things sometimes. So, okay. Let's fix our points now. Threw me off. Negative 3 and positive 3. That's what I get for rushing through this video. Okay. So here's our 3 zeros, which means we can write our zeros up here. 0 plus and minus 3. Now, since this graph is even, that means my right and left hands are going up towards positive infinity. I think here, because we took the square root of 0 in this area right here, technically the square root of anything is plus or minus, but 0 does not have plus or minus. So I think this is telling us that the bounce here is going to be at the 0. I'll have to confirm with Miss Kennel. That's a little odd for me, but I'm pretty sure that's what it is. So our graph should be a nice W. For sure, the graph looks like this. What I'm not 100% sure on is this 0 a bounce because it is the square root of 0? Something to consider. But don't worry, there's no bounce on 0 on your quiz. Again, so you can use this practice on your quiz tomorrow. There are extra credit, extra practice worksheets on the desk with the fan, the big table over here I have in the back. So please grab one. If you complete the extra credit worksheet, as long as you complete numbers 1, 2, and 3, I'll make a note here for those visual people. Complete extra practice worksheet numbers 1, 2, and 3, skip 4. And you can turn it in tomorrow with your quiz. And honestly, I don't mind if you use it on your quiz tomorrow. So if you complete that extra credit, extra practice worksheet, we'll say it'll give you 10 points on your quiz. And you can use that as well as this worksheet we just did together on your quiz. Hope that sounds great to you. Sounds great to me. Okay, please email me if you have any issues with the video or anything I've spoken about in the video today. I will be accessible by email all day today, so please don't hesitate to email me. Yeah, all right. Please let me know if you need anything. I will see you guys tomorrow.